In this video, I will continue the discussion of symmetry, but we'll change it to talk specifically about functions. And we give symmetry to functions particular names. We will talk about in this section whether or not a function is even or odd, and these refer to symmetry about the y-axis or origin. Now note that a graph that is symmetric about the x-axis fails the vertical line test, right? If we have this sideways parabola that we just looked at before, a vertical line touches more than one point on the graph, and so it's not a function. Therefore, a function will not have symmetry about the x-axis. We define an even function to be a function whose graph is symmetric about the y-axis. Recall that symmetry about the y-axis meant that if the point xy was on the graph, the point negative x, y was on the graph. That is, opposite x values have equal or the same y values. In function notation, we state this, that f of negative x is equal to f of x, right? If the point x, y is on the graph, y is equal to f of x. If the point negative x, y is on the graph, y is the output for the input of negative x, so we say that y is also f of negative x. So if f of negative x equals f of x for every x in the domain of f, then the function is even. For a function to be an odd function, its graph is symmetric about the origin. So think about odd, origin, both starting with O's. And remember that in this case, if xy was on the graph, negative x, negative y was also on the graph for every x in the domain. So this is saying that f of negative x is equal to the opposite of f of x, right? Because y is equal to f of x, but negative y is equal to f of negative x. So when the x values are opposite, the output values are also opposite. So we say that as opposite x values have opposite y values. So when we want to determine if a function is even, odd, or neither, we can certainly graph the function and look at it visually to see if it has symmetry about the y-axis or origin, but we can actually do this algebraically. To determine if a function is even or odd, we're going to find f of negative x and compare it to the original function. Remember, in function notation, f of anything means we replace the input with what is inside parentheses. So if we have the function f of x is equal to x squared minus 3x minus 4, we will find f of negative x by computing, in parentheses, negative x, quantity squared, minus 3 times negative x, and then minus 4. When we simplify, negative x quantity squared is just x squared. Negative 3 times negative x is plus 3x minus 4. So we need to ask ourselves, is this the same function? If this is the same as the original function, then it would be even. But this is not equal to the original function because our signs on the 3x are different, so it's not even. To be odd, it has to be the opposite of the original function, which would mean that each sign has to be opposite. But that is not the case because only the sign of the 3x is opposite. So this is neither even nor odd. What about f of x equals x cubed minus 4x? So to determine if it is even or odd, we first find f of negative x. which is in parentheses negative x, then we cube it, minus 4 times negative x. When we cube negative x, we get a negative x cubed. Negative 4 times negative x is plus 4x. So is this the same as our original function? No. Is it the opposite of the original function? And note if I factor out a negative 1 from negative x cubed plus 4x, I have the opposite of, in parentheses, x cubed minus 4x. So this is the opposite of f of x, which means that f is an odd function. Part C is f of x equals the absolute value of x plus 3. We want to find f of negative x, which is the absolute value of negative x plus 3. But the absolute value of negative x is the same as the absolute value of x. The absolute value of x plus 3 is the result, and this is the same as the original function. So since f of negative x is equal to f of x, we say that f is an even function. And note that, I know that the absolute value of a number and its opposite is the same thing, which is why I can conclude that the absolute value of negative x is the absolute value of x. Also remember that this is one of the transformations of our basic function, so if I wanted to graph this, remember the absolute value of x is just that basic V-shaped graph. If I add 3, that's an outside change, which will shift it up 3 units. And then if I just look at the property of the graph, it is symmetric about the y-axis, and so therefore it is an even function.